Away. Cool stuff. So this is of course the beginning of Euclidean geometry, and part of that we're gonna talk about triangles. After talking about triangles, we're gonna go further and talk about quadrilaterals. Then we jump into midpoint theorem, midpoint theorem, and then that'll be the end of geometry for grade 10. Right, so talking about trigonometry, we have different kinds. You have to know their names, but also most importantly, you need to know their properties. Right, because sometimes you will get, they won't tell you what type of a triangle this is. And the thing is, knowing the kind of triangle you're dealing with, it helps you with certain things. Right? Certain things, your angles, your sides, it becomes much easier to find, Like for example, if you know that this triangle, it is a right angled triangle, you know for sure that, man, I'm gonna use theorem of Pythagoras to get my sides, right? And so forth and so forth. So not to waste any time, we have the first one, which is scalene, right? Scalene triangle, and that is a triangle which there's nothing equal, right? All angles are not equal, all sides are not equal, right? Remember, a triangle, it is a shape that has three sides and three angles, right? Yeah, triangles, three sides, right? And what we are saying about scalene is that all these three angles, they are not equal, and all these three sides, they are not equal. I'll just for illustration, say this triangle. Yeah, I mean, I tried. It is a scalene triangle, right? Because you see, of course, there's the shorter side, and this would be the longest side, right? You also see that this one is shorter than this one. Let me just say we have A, my word, A, B, C. So for here, you are seeing that BC is actually smaller than or shorter than AC, right? Because B would fall around about here, but since there's an angle, it is tilted upwards by an angle, probably it will be somewhere here, right? But it's not the same, right? So yeah, this is an example of a scalene. All angles not equal, all sides not equal, right? Then we go on and talk about isosceles. Isosceles also has its own specialties. There are only two sides equal, and therefore two sides two sides equal, and therefore two angles equal, right? Outside that, you know what I'm saying? I don't know what else we can say, but that's just it. Good example of an isosceles triangle is this one, right? Actually, yeah. There's a good example of an isosceles triangle. So these two sides, they are equal, and this angle also, they are equal, right? So there's an isosceles where two sides are equal and two angles are equal, right? So to know these properties, we have an equilateral triangle, and as for equilateral triangle, every angle equal, every side equal, right? So here you'd have something like this: 1, 2, 3, right? And then all these sides, they are all equal, and all these angles also, right? They are all equal, implying that each angle, right, is equals to 60 degrees, because then 60, 120, 180 degrees, making angles of a triangle, right? Cool. Let me jump to the last one here, where we talk about right angled triangle. We have been dealing with this one for quite some time now. Yeah, so right angle triangle is the one that has a right angle, right, which is a 90 degrees angle, right? So there's a right angle triangle with its own hypotenuse whatsoever. Yeah, and we talk about acute. Okay, so acute angles and obtuse angles, né? So acute angle is an yes, yes, of course we have we have acute angles, we have obtuse angles, right? But I meant to say triangles. But of course you know that acute angle is any angle below 90 degrees, right? And obtuse, I think it's between 90 and 180, I think so, right? But it's definitely above 90 degrees, right? So acute triangle is a triangle made up with angles that are all below 90 degrees. For example, equilateral triangle is one of the acute angle. Acute triangle, come on, man. Yeah, acute triangle. So yeah, and then obtuse angle, you will have an obtuse angle in your triangle, right? Good example could be this kind of a triangle. Right, so you already know that, because you know that let me draw this. What you know is that the angle from here, right, from this line all the way to the straight line, it's 90 degrees, and we have a couple of, right, degrees that side. So you already know that this angle, all of it, it's what, this angle is an obtuse angle, implying that the triangle itself is an obtuse triangle. Cool. Yeah, these are the kinds of triangles we have. Yeah, let's see what we're going to talk about, right? So now that we have spoken about triangles, we go further and talk about triangles. Right, there are two things which we speak about. It's congruency and similarity. Congruency and similarity. Right, so for congruency, I remember one of my teachers, my math teachers, explained it so well. It was like congruency is like we are basically saying that these two, if we say that the two shapes are congruent, we are saying that if we put the two shapes together like this, right, you would not tell, okay, they would fit exactly on each other, like they would fit properly, you know what I'm saying? It's like, for example, if you take a bank card from Capitec, you take a bank card from ABSA, right, and you put them together like this, the two, they will fit properly right on top of each other. And yeah, so we can then say those are congruent. But for when we are talking about triangles now, we have a few things. As you can see from what I have here, there are 4 things that we need to check, right, when we are checking for congruency, right? And it's fine if your triangle happens to qualify for many of these, but we just need one to prove that it's congruent, right? You need one. So I'll start with them one by one. So here we have a right angle. It's 90 degrees HS, which is 90 degrees hypotenuse and side, right? So here, what we are saying is that, say for example, we have a right-angled triangle, right? And we have another right-angled triangle, right? This is 90 degrees, 90 degrees. Now, and then we are told that this side and this side, they are equal, right? Yeah, and also this side and this side are equal, right? So let me say this and that. Yeah, so now what we see is that yes, we have a 90-degree angle, right, which is the 90 here. We have the hypotenuse sides, they are equal, right? And moving further from the hypotenuse, we talk about this one other side, right? It could be this one or this one, right? But just we need 2 pairs of sides that are equal. Like here you see the hypotenuse are equal, here this one and this one. So you'd still be fine if say for example it's instead this 2, right? because it's one other side, the hypotenuse is equal, and you have a 90-degree angle, right? So all of that, what does it say? It says that the two triangles are actually congruent, right? Cool stuff. So another one we talk about SSS, right, which says side side side, right? So basically there with side side side, say for example this side and this side, this side, this side, this side, this side, right? So what you see here is that this side equals this side, this side equals this side, this side equals this side, okay? So when that happens, you will then say that the two triangles are congruent to each other, right? And something I forgot to mention initially, for congruency, it is the symbol that we would use, right? So for example, say this is a triangle A, B, C, D, E, F. We would then say triangle A, B, C is congruent to triangle C, D, E, F, right? To say that they are congruent, né? Cool. We talk about another one, which we have, okay, right, we have two triangles, né? And then say this angle equals this angle, right? This side and this side, this side and this side. So you have, oh, let me, so now you see that we have an angle, right? We have a side equal, we have a side equal. Then you will say the two triangles are equal. And also, by the way, when you're proving that the triangles are congruent, or yes, in this case we're talking about congruency. So when proving that the triangles are congruent, you would say triangles are congruent, and you have to give a reason why you say that, right? So I get it, like before, I will show you with this triangle, right? Say we are doing the side side side, né? I would say BA equals to DE, right? Then I would say BC equals to DF, right? Then I would say AC equals to EF, right? But also realize when I'm saying these things, I need to say the reason why I am saying that, of which in this case it will be given, right? Because I did tell you guys that they are equal, right? And there are other cases where you will have to calculate, and then you would say, oh, the sides are actually equal. And then in the other sides, it will be told to you that they are equal, so of which you would say it's given, right? Yeah. So you see here, there's a side, there's a side, there's a side. Then you would say, therefore, triangle ABC, triangle ABC equals to, no, it's congruent to triangle what? Triangle D, E, well, let me start with E, yeah, EDF, right? EDF. Then you would state your reason to say reason is side side side, right? Yeah. So now also, while we are on this part, something I'd like to illustrate with the way also in which you name your triangles. Look at this. Look, so we are saying AB equals to ED, right? Let's see the picture. Wait. Right, so AB, here's AB, it is equals to ED or DE, right? We have BC, BC must be equals to DF, BC, DF, right? You see, and then AC must be equals to EF. Let's see, AC, EF, AC, EF, right? So the way in which you name your triangles also, like from the name themselves, we must be able to tell, oh, this side and this side, therefore they are equal, this side and this side. Oh, okay. Because also, let me now make another example. So cut, delete. So say you have two triangles. You have two triangles. Yeah. So with these two triangles, you find out that this angle equals to this angle, right? And this side equals to this side. This side equals to this side. Just saying. So then you have, let me go, A, B, C, D, D, E, F, right? And then you will then say, we are now proving, we are now proving, you will then say AC equals to DF, right? You then say, oh, okay, that's a side and it's given, and that's a side, right? And then you would say BC equals to EF, right? It's given also, right? And it's a side, right? And then angle B equals to angle D, right? And it's given, and that's angle. So you would then say, therefore, triangle ABC is congruent to, remember I said the way in which we name our triangles is very, very important, right? So you will have D, look at AB, DE, F, because you still look at BC, this is BC must be equals to EF, right? AC must be equals to DF, right? So the way in which, oh, I forgot the triangle, the way in which you name your triangles is very, very important. So now I haven't mentioned it. So now you would say then the reason for congruency here is side, angle, side, right? So you see that on the problem, it was not given to us that side AB is equals to DE. It was not given to us, but for after proving that these two triangles are congruent, we can then conclude to say, right, you can then say, therefore, right, AB equals to DE, right? And then you can say proven, right, or from congruency, right? Because we just shown that the two triangles are congruent. And in fact, what I'm saying now here, we're gonna use it we're gonna use it when we are doing a midpoint theorem. So just hang in there with me, yeah. Cool stuffs. Say now we also have two triangles given to us, and with those triangles we are told something, right? They tell us that, look, oh my word, what did I do? We are told that this angle equals to this angle, right? Now you see that this angle equals to this angle, so your reason you will have angle, and then this side equals to this side, you will have side. This angle equals to this angle, you will have angle, and then you will say the two triangles are congruent, the reason, angle, side, angle, right? Yeah, so this is, I hope this is not a lot, right? But what I can promise is that once we do a couple of examples, we'll see exactly what how the calculations are done, right? Let's see if I did. I bet. Cool. So we do have a couple of problems. Cool. So I'm gonna cut short this video, right? And not to make it long, I will make another video next video. We're talking about similarity, and then we'll do problems afterwards.